Okay, so yesterday you guys did really well on your practicals, very well. I know you guys were nervous coming in, but I hope you're a little less anxious now, seeing how those are run. So you guys did really well on that. So you know that sensory information comes through the dorsal side and then through the dorsal horn. And if it's a muscle spindle response, it then jumps right over to the alpha motor neuron, which innervates the same muscle that the muscle spindle is in, right? And that alpha motor neuron is going to be the ventral root, right? The ventral root, and that's going to innervate the same muscle that the muscle spindle's in, and that's going to cause it to contract. Okay, and you'll see that when you do the patellar tendon reflex. And then we talked about the Golgi tendon reflex, and that is one that creates an IPSP and causes the muscle to relax, right? So this one is located in the tendon, and when the tendon starts to stretch, that's going to fire the stretch receptor, and it's going to send a signal, right, a sensory signal to the central nervous system. It's going to jump over to an interneuron. The interneuron is then going to jump over to the alpha motor neuron, and the alpha motor neuron out of the ventral root, and then the spinal nerve, and that's going to come to the muscle that the tendon is attached to and tell it to relax. And this is to prevent tendon damage. Okay? All right, that's what we did day before yesterday. Yesterday we did the practical on the spinal cord anatomy. Today we're going to do the withdrawal reflex, and then we'll do the withdrawal reflex with reciprocal innervation. Okay, so if you want to follow along in your books, we'll get also, hopefully we'll get to cross extensor reflex too. But if you want to follow along, I'm on page 408. Okay, and these are the things I'm going to put on the board here today. Does anybody know what's on the board? What this is? This is from 8th grade science. Anybody know what's pictured there? You should from bio. Not the houses. You know what that guy is? No. Nobody. You don't recognize a virus? Okay. Alright, we'll get rid of that guy. That's a consohedral virus. How about this guy? You know what that is? Oh, come on. It's junior high. You guys got to remember this stuff. It's a bacteria. Good. It's a bacteria. And then what would that be on there? Bacteriophage. Good, Reagan. It's a bacteriophage. It's a phage. All right, very good. Okay. I was worried there for a minute that you guys weren't going to know this stuff. All right, so let's talk about, let me turn this guy just a little bit there. So let's start off talking about, let's do withdrawal reflex. All right, so let's say, here's your hamstring. We'll do I'll use the same example in your book here. So basically I'll be explaining what you're looking at if you have your book open. So there's your hamstring, and then underneath there you've got your quadricep. So these are groups of muscle: quadricep group, quadricep group, hamstring. So this is top of the thigh up here, and then this is bottom of the thigh down here. And then we've got your gastrocnemius and soleus, right, like that. And there we go. And then we've got your patella there. And then you've got your patellar tendon, right, like that. Patellar tendon coming down to the tibial tuberosity and attaching there. And then, well, wait, there's more. And then there's your tibia right there. Okay? So this is your knee, right? This is your knee. So that's the point in which the knee will bend. Okay, like that. All right, so here's what happens. I'm going to just draw in a foot here. So let's say, now listen, if you hear angels sing as I'm drawing, don't be alarmed. That happens sometimes. There's your foot there. Up like that. So there's your skin. So this is the outline there. That guy. Like this. Like that. Okay. So everybody sees what's going on there, I hope. Okay. So the example that is in your book is of a person stepping on something. Okay. So let's say a person is walking and they step on, I don't know why this would be there, but they step on this giant tack. right? Maybe there was some sort of a tack spill, and so there's tacks lying around everywhere. So you step on that. So the first thing that's going to happen is you're going to have nociceptors there, or pain receptors, and they're going to sense that pain, okay? So that tack is going to be pushed into your foot, and you'll be like, oh my gosh, that really hurts. But you can't say that really hurts until you perceive the pain, okay? Until that signal gets to your brain, it doesn't hurt. The signal might be firing, but until that gets to your brain, you don't know that that hurts. So this is going to be your sensory neuron, and it's going to send a signal, right, all the way, and that's going to go dorsal root. There's your dorsal root ganglion, and that's going to go dorsal root. And I'm going to draw this back in, make sure everybody can. Oh, can you see that over there? Okay, barely. Oh, hey Claudia, a little late to the party, buddy. So that one there. So there's your dorsal root, and then there's your dorsal horn, lateral horn, ventral horn, lateral horn, dorsal horn. And you guys did really well on that yesterday, by the way. And you got, well, you know that. You were here. And then there's your central canal. Right? Now, this is your gray matter. Some of you had a little struggle with that, gray matter versus white matter. So that's your unmyelinated axons in your cell bodies. And then here, this is going to be the dorsal side. So that's the dorsal sulcus, ventral fissure. Okay. So this is a spinal cord cross section. Okay. All right. So now we've got this signal. This sensory signal is going to come in through, and we know this, the dorsal horn. The dorsal horn, like this. It's going to collateral up to the brain to let the brain know, hey, I stepped on something. It hurt, okay? And then it's going to synapse. So we're going to have an interneuron here. Okay, an interneuron. It's going to synapse with an interneuron. Remember, an interneuron is just a little tiny piece. Okay? It's not an alpha motor neuron. It's just a little jumper cable. Okay? And then that's going to synapse with your alpha motor neuron out the ventral horn, ventral root, and that's going to innervate muscle. Here's your neuromuscular junctions, and that's going to innervate the muscle to contract and withdraw your foot away from that painful stimulant. Okay? And this is called the withdrawal reflex. So this is an excitatory signal. We'll call it an EPSP. Okay? So this is an excitatory signal. All right? Not inhibitory, excitatory. Actually, I'll just call it excitatory. It's an excitatory signal. That's going to cause this muscle to contract and withdraw from the painful stimulant. The same thing happens if you touch something hot, right? If you're up against a grill when you're little, right? The kids always run around and they're like, "Stay away from the grill, it's hot." Your mom and dad like, "Ouchie, ouchie," and the kids and they touch it and they're like, "Yeah," right, like that, real fast. "Oh, it's so hot," right? That withdrawal reflex, you don't have to think about that because look, here it goes, boom, 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 withdrawal. Yeah, it lets the brain know, but you don't have to think about withdrawing your hand. Could you imagine that? Putting your hand on the stove. Oh boy, that hurts. Should I withdraw my hand? Yeah, I probably should. Pull it away, right? By then, you'd have a lot of damage. So this happens very, very quickly, right? So this is an involuntary action. You can create IPSPs or EPSPs to quell this response or make it more exaggerated, but you don't have to think about this. Okay, so this is your withdrawal reflex. Your withdrawal reflex. Any questions about that? So withdrawal reflex goes receptor, sensory neuron, dorsal rootlet, dorsal horn, interneuron, ventral horn to the alpha motor neuron, ventral horn, ventral rootlet, ventral root, excitatory signal to the muscle to cause the withdrawal. And I drew this on a lower limb, but it doesn't have to be. Questions about that? ¿Es claro? Más preguntas, problemas, comprehendes todos aquí? Yeah. Okay. So now, actually, I'm just going to add to this one. So now let's do withdrawal reflex with reciprocal innervation. Okay, so this is withdrawal reflex, but now we're going to do with reciprocal innervation. Okay. So if you're looking in your book, we're on page 408, and we're on figure 12.9. Page 408, 12.9. Okay, so right here we've got this, and I'm just going to pick up here. So you are contracting this muscle to pull away from this painful stimulant. This one here we said was going to the brain. Okay? To the brain. But wait, there's more. This is also, I'm going to go upward here, so I'm going to have to move this just a little bit. Okay. And this one, I hope it doesn't fall. There we go, just like that. Okay, this one's going to the brain, but there's also going to be another collateral. Okay, and it's going to go up to another section, right? Another section of the spinal cord, which I'm going to draw right here. So I'm just going to draw the cross section of this guy. So we got dorsal horn, lateral horn, ventral horn, lateral horn, dorsal horn, central canal, and then got dorsal sulcus and our ventral fissure. Okay. So what this is going to do ultimately, so withdrawal reflex is pulling it away, right? Withdrawal reflex with reciprocal innervation is withdraw this one, but relax this one. Okay? Imagine if this one was excitatory and so was this one. What would happen? The leg wouldn't move. It would just flex, right? It would be like, oh my God, it hurts. Oh, or it would flex out, right? It might look cool, but you're not going to withdraw from the painful stimulant. Okay, so this one's going to go up. And it's going to go up here. And it's going to synapse. Go up here it's going to go up in the dorsal horn. And then it's going to synapse with an interneuron. Just like down here. Okay, interneuron. And then that interneuron is going to synapse with a alpha motor neuron. And then that alpha motor neuron is going to innervate the antagonist, so the opposite side to this one. Ventral horn, ventral rootlet, ventral root. Boom. Okay, but this one is inhibitory. Hold on, I forgot how to spell for a second. Inhibitory. Okay, so these are two different muscles. And I'm going to label these just so you guys are clear with my drawing here. So this would be a hamstring. Okay, and this would be this would be the quadriceps group. Okay, so this is your, up here, your vastus medialis, your vastus rectus, vastus femoris. Okay. So this is your quadriceps. This is your hamstrings. Okay. Questions about that? So the difference between withdrawal and withdrawal with reciprocal innervation. Withdrawal is simply an excitatory impulse coming from an alpha motor neuron to withdraw from a painful stimulant. Withdrawal with reciprocal innervation is the same thing, but inhibiting the antagonist muscle so that you can move it. Any questions about that? No, we're good. Okay. So what I want you guys, see where we at. So we got ascending and descending tracks. We're good with that already. All right. Let's see. Well, let's just add to this, shall we? Okay, so all these things kind of happen in conjunction with each other. So if you're following along in your book, just turn the page there, or look over the next page. We're on page 409, and we'll talk about withdrawal reflex with cross-extensor reflex. Okay, so this is withdrawal reflex. So this happens with one leg, but the other leg. So what has to happen? Look, you guys should be aware of, this simple fact. If you withdraw yourself from a painful stimulant with one leg, right, like, ow, like that, and pull your leg up. I should back these cameras up too. But anyways, you withdraw, you step on something, and it hurts, right? So, ow, you lift that leg up, okay? What's the other leg have to do? What's the other leg have to do? Should it also lift up? Like if you're withdrawing, like, oh, like that, lifting your leg. Like you lift your right knee, right? Like, ah, that hurt. What's your other leg going to do? Is it also going to lift? No, it can't, right? You have no feet on the ground, and you will fall right on attacks. You fall on a whole pile. Okay? So think about this. Withdraw this one. What does the other one have to do? Evan, what's your other leg have to do? Is it going to straighten out? Is it going to bend? What's it going to do? Evan, take the weight and exactly right, Evan. That's right. If you can't see, he typed in there, take the weight and straighten. Exactly. So you keep your balance, you don't fall down, right? So this is withdrawal reflex. This is withdrawal reflex with reciprocal innervation. And now we're going to do withdrawal reflex. Reciprocal innervation happens also, but withdrawal reflex with cross-extensor reflex. So there's two different reflexes that happen at the same time in conjunction. Okay, so here we've got collaterals, right? This one's going to the brain, this one's going up to another level, and then interneuron inhibitory to reciprocate. Okay, I'm just going to draw another collateral onto this. I'm going to use a thinner green. Maybe you can see a little better. Okay, another collateral here. Okay, see that coming off there? So this collateral is simply going to go to the other side of the body. Okay, to the other side of the body. So this one's going to come right about here. It's going to synapse with an interneuron also. Okay, so also with an interneuron. This one's going to go across to the other side of the body. Okay, like that. And then it's going to synapse with actually it's going to synapse on the same side and then jump across. So it's going to synapse with an alpha motor neuron also. And that alpha motor neuron is going to exit. Just like motor neurons do, the alpha motor neuron is going to exit. Actually, it goes across like this. It's really weird. It's going to exit the ventral horn, ventral root, and that's going to go to the opposite leg. So let's say this one's the right leg. Okay. This one's going to go over to the left leg. Okay. And this one's going to cause this muscle, this quadricep muscle, to straighten out. Okay. So now, here's our quadricep. There's our hamstring. Okay. Here's our patellar tendon, our patella. Here's our gastrocnemius, soleus muscles. Okay. Patella. Tibia. I got a little carried away with that muscle. Tibia. There. Okay. area of bend. Skin around that guy. That is a good foot. I'm not bragging or anything, but that might be the best foot that's ever been drawn in Greenville High School. Okay, so what this one's going to do, this one's going to come over, and it's going to innervate the quadricep. There's your neuromuscular junctions, acetylcholine going across, attaching to ligand-gated ion channels. Channels open, sodium goes in, depolarizes the postsynaptic membrane, yada yada yada. Right? Sarcoplasmic reticulum releases calcium. Calcium attaches to troponin. Moves tropomyosin out of the way. Active sites exposed. Globular head. Quadricep straightens out, flexes. Okay, so this is excitatory. Okay? So this puts it all together. This one is withdrawal reflex with cross extensor reflex and also reciprocal innervation. Okay? Any questions about that? Okay, what do you got here? Yeah, I do. I got the other camera on. I'm recording for YouTube. I'll put it on the classroom. You can't see the foot? Which foot? This foot? There you go. Is it better? This foot. Okay, I'm gonna take this one up so you can see closer. Okay, so I'm gonna put this one on the YouTube for you. All right, so this is withdrawal reflex, shown on the bottom there. Reciprocal innervation, shown on the top there, on the quadricep. And then with cross extensor, over here. Okay. All right, stop this guy.